Hello there. So today we're doing a lab called the Hot Wheels lab. And basically the objective of this lab is we're going to evaluate horizontal projectiles. And we're going to do that by turning this Hot Wheels car into a horizontal projectile and have it launch off this table. And how we're doing that is, you can see here, what we've got is a stack of books, and we've got a ramp, and the ramp is going to speed up the car. And the car is going to come down to the table, run across the table, and then fly off the end of the table to the floor. And so what we're trying to do here is we're going to gather some data about what's going on top of the table, so we understand the velocity of the car as it goes off the table. And then what we're going to do next is we're going to measure how far, we're going to do some calculations, figure out, basically predict how far off the table the car is going to go ahead of time using projectile equations for horizontal projectiles, right? And then once we do that, the last thing we're going to do is run this, measure how far it goes off the floor, off the table, and see if our measurement is close to our prediction. Okay? So first thing we're going to do, the first problem we have is that in order to make this a horizontal projectile and to do this kind of problem, in order to know or make an estimate, a mathematical estimate of how far off the table it's going to go, well, that depends on the horizontal velocity of the car. The higher the horizontal velocity, the farther the car is going to go away from the table when it flies off the table. So I have to know the horizontal velocity of the car. So that's the problem, that's the first problem you face. How do you do that? So I'm going to give you some help on that by showing you this video, and you can work out the details. So first thing I'm going to do, you're going to notice, I'm going to send this down this ramp. At the bottom of the ramp, there's a smooth table, and this car has very smooth wheels, very low friction. This is 1 meter from the end of the ramp to the end of the table. That's the distance. So the distance on the table, the displacement on the table, is 1 meter forward. Okay, so that's the distance the car is going to go. So if I measure the time it takes for the car to go from here at the beginning of the flat table to the end of the flat table, which the velocity should be pretty constant, right? I know that time. If I know the time and the displacement, I can calculate the velocity. Okay, so let's do it. We're going to do about 5 trials because this is going to be very fast. And I'm not going to hit the button quick enough, and so you're going to see different numbers, and then what we're going to do is take an average. Okay, so here we go. I'm going to try. Okay, so we're getting ready to go. Let's do it. Here's our first trial. Okay, first trial, 0.68. Okay, let's do the other 2. We're going to do 3 trials total. I think 3 trials is enough. Let's see if they're consistent. Oh, really good. I'm doing good. I'm doing really good here. So look at this. Very consistent with the first trial. Okay, and one last one. And hopefully this will be consistent too. Let's hope it is, and then we can have some confidence. I'm actually measuring the time it takes for the car to go from here to there pretty accurately, okay? Okay, here we go, last time. Okay, now hit the side a little bit. That might have slowed it down, but it wasn't bad because the total time on the last trial was 0.7, which is great. Look at that. So now I want to get the average of these 3. So to get the average, I'm going to add them all together, and then I'm going to divide by 3. Okay, so to get the time average, it's 0.68 plus 0.65 plus 0.7 divided by 3. Okay, so I got my handy calculator here because I just got this data. I didn't have it ahead of time. So 0.68 plus 0.65 plus 0.7, and then I divide by 3, the number of total trials. And the average, I'm going to round it to the nearest 2 significant figures. So it's going to be 0.68 seconds. That's going to be my time. Okay, that's my time. So the distance on the table is 1 meter forward. The time I spent on average going across the table, the average was 0.68. So now you should be able to calculate the velocity, the average velocity on the table. And since this table is horizontal, you now know the horizontal velocity of the projectile coming off the table. So calculate that velocity, and then using the horizontal projectile formulas, calculate how far off the table the car went. And then we're going to do it in a minute and see actually how far it went and see how it compares. Okay? Okay.